Okay, I am recording this, so if you need to look back on it. So this little part right here, the distance formula, I'll take basically 2 class periods to do that. So I get my notes out. All right. Some of this might look familiar to you. Let's tell you what I'm going to do. Let's grab this thing. Remember doing this in Algebra 1? Whoops. This thing right here. Well, some people might call it a grid. I guess it's kind of grid-like, but we don't really call it a grid. It is a graph. But we have a special name for it. It's kind of a fancy name. Yeah, you could call it a coordinate plane, so write that down. You got your notes out? I don't see too many people writing. All right, so we call it a coordinate plane. We'll talk about that in a second. There's another real fancy word named after a guy that lived a long time ago, and they call it a Cartesian plane. It's the same exact thing. It's just 2 different names to call it. A Cartesian plane. Now, why in the world would they call it Cartesian? Because it's named after somebody a long time ago. And it's, let's see, he was born in 1596. 1596. He was French, and his name is Renee. It looks like Descartes, but we say Descartes. All right? So it's Renee Descartes. It's this guy, he lived from 1596, and I wouldn't know this except I just looked it up. All right? It's to 1650. All right? So a long time ago. He was one of the ones that kind of came up with this. He wasn't just a mathematician. This isn't the only thing he ever did. He was also a philosopher. He was a scientist, and he was also a mathematician. And but they give him credit for this. I'm not sure exactly like when he got credit for it. I don't know if it was after he died. I don't know. I'm not really that interested, to tell you the truth, about it. But this does come from this guy right here named Renee Descartes. And I just happen to have a picture of Renee Descartes. Well, I just found this like minutes before you walked in today, and I thought I would just show you what this guy looks like. All right. So there he is. That's Renee Descartes. All right. He's a French guy, and with a girl's name. Actually, I think in French, Renee is probably a guy's name as well. But in our culture, we kind of think of it as a girl's name. Of course, my name is a girl's name as well. So it's Aaron. So there's girl Aarons, right, as well as boy Aarons. What? No. I forget who said that. I should know it. It's like Plato or something like that, Socrates or somebody. You think it's him? I don't know. Well, guess how you could find out? That's right. Okay, back when I was in... Logan, I'm in the middle of talking, and you're yelling across the room. Okay, listen. Back in my day, when it was really old time, everything was black and white. We had no color or anything. No, just kidding. If a teacher would have said, look it up, what do you think we would have done? We had no Google. We had no... Yeah, go to the library or almost every home had a stack of books like this wide, went from A to Z. Anybody know what they were called? Encyclopedias, that's right. So we used to have encyclopedias. So we would have to look him up in an encyclopedia. But now you got Google and you got every answer to any question. You have every answer to every question you could ever ask on Google, which is absolutely amazing. But you guys grew up with it. You're used to it. To me, I'm still amazed that you can just type something in and get an answer for anything. So here we go. Now, this is called a Cartesian plane. Why did I move it over there? Let's keep it in the middle. So there's a few things about this Cartesian plane or coordinate plane that we need to know. Do you see the big, thick white lines right there? We call each of those an axis, all right? And we give this one a name. The one that goes horizontally right here, does anybody remember which one this would be called? You did this in Algebra 1. Right, yeah. So this is the x-axis. That's correct. And the up and down one, the vertical one, is the y-axis. All right, so x is horizontal and the y is vertical. You didn't learn it. Well, you think you learned it, but a lot of people didn't. So it's good to review. All right, so this is an x-axis, this is a y-axis. And what about where they intersect? We have a special name for that. Okay, we have a point right there. Exactly right. So this is called the origin. I don't know. Can you read it if I put it here? It's the origin. It means the beginning. Okay, this is where we start. That's what origin means. That's why we call it the origin. All right, it's got a beginning. This is where we start. No parabolas. Wait till Algebra 2, then you'll have parabolas. All right. So let's do this. We could also call this a coordinate plane because if I put a point, if I put a point right there, okay, what I could ask you is, what is the coordinate or the location? When we say coordinate, it means where is it located? Okay, what's the location of that point? Well, I could say, well, if you go over up a little bit to the right, maybe about 40. So if I asked you where is that point located, you might say, well, it's kind of like northeast about so far. I don't know. You could have weird ways of saying where that point's located. So what we need to have is we need to have a way that everybody understands, that everybody can say, oh, that's where that point is. Okay, I need to know where that point is. It's just like GPS or something. You've got to know where the coordinates are. Sometimes, you can put in a place, an address or something that tells you where to go. But like if you're out in the middle of the woods, sometimes there's no name for a town, there's no name for a street or anything, but there are coordinates, okay, to let you know. Like if I go hiking, I don't have one yet. I'm going to hopefully get one by next summer. But it's a little GPS, little satellite GPS that you just hook onto your backpack, and somebody can track you from their computer or their phone, and they can see exactly where you are. Even if you're not in a town, even if you're not by a road, even if you're in the middle of the woods, they can see your coordinates, where you're located, all right, which is kind of cool. And you don't even need cell service because it's satellite. As long as you're not like in a cave or something and you got a bunch of trees over you, you got to have kind of sight to the sky. Yeah, and if I go for a long trip, she could get online. I could just and you can also even text through the satellite and that kind of thing. It's a little expensive, but if I'm gone for a long time, and it's good. Okay, I'm talking. So we got to find out where that point is, and we call that a coordinate. So here's how we do coordinates. We do it as an ordered pair. This thing is called an ordered pair. Yeah, this is an Algebra 1 topic, okay? But it's also a geometry topic, okay? We do a lot of stuff in here in geometry with this stuff. So it goes both ways. It's good to review it, even though you've seen it before. It's called an ordered pair. Well, it's called a pair because there's going to be two things in here. It's separated by a comma. And it's called an ordered pair because one of them has to go first. One of them has to be second. You remember which one is first? The x is first, and then the y is second. It's an ordered pair. It has to be in that order. You don't make it yx, okay? It's got to be xy. It's a pair because there's two things. Now, if I wanted to know where that point is, right here, I'll call it point A, all right? If I want to find the coordinate of point A, where do I begin? Where do I start? Where do I begin? At the origin. That's what origin means. It means to begin, doesn't it? Jason, stop. So we start at the origin, and look at which direction we go. First, we go in the x direction. The x direction is left and right. Okay? The y direction is what? Up and down. Okay? So we start here. If I want to go to that point, am I going to go left or am I going to go right? I'm going to go right. Okay? Let's count how many places that I go. 1, 2, 3, 4, 5. So I'm right here. I go 5 places. Now I got to get up to that point. So where do I go now? I go straight up. Let's see how many places. 1, 2, 3, 4. So that means I went over to the right 5 places, and then I went up, which is positive. How many places? 4 places. So that is the coordinate of point A. So I could ask you that on a quiz. I could put a graph, put a point, put a letter, and I can ask you, what is the coordinate of point A? And you would tell me 5, 4. Make sure you put a comma. Make sure you put parentheses. Don't just write 5, 4. Don't even just do that. Okay? Make sure that you put it in parentheses and a comma. If you don't have all of that stuff, I'm going to mark it wrong. I'll tell you right now because I want you to do it. Casey, you had a question? Ugh. Thought you had a math question. Come on. All right. Let's see what else. Oh, here's another thing we're going to do. Let's put this in a different color. That's exactly what I'm going to do. Okay, so let's take a look. See this X and Y axis? It breaks it up into basically 4 different areas right here. Right? You got this top right, you got the top left, you got this bottom left, and you got this bottom right. Well, it's broken up into 4 places. What's the prefix for 4? Quad. Okay? All right, so that's what we use for 4. And so somebody already said it. We call it a quadrant. Quad, R-A-N-T. It's called a quadrant. It's just the area, okay? It's just the area right here. Now, we number them, and we use specific types of numbers. What kind of numbers do we use? We use Roman numerals, and which one is the first one?
The first one is the positive, so it'd be where that A is.
Okay, so it's in the top right one, okay? So this is the first quadrant. So I'm going to write it Roman numeral 1. And now we go clockwise or counterclockwise? Which would be? Think of a clock, right? See the clock? If you go the opposite direction, right? If this is 2 o'clock, we go 1 o'clock, 12 o'clock, 11 o'clock. Okay, that's counterclockwise. So this would be the second quadrant, the third quadrant, and the fourth quadrant. Okay, that's pretty important because a lot of times they'll say what quadrant is a point in, right? And you have to tell. Now, let's see what else we want to say. We already know that this is 5, 4. Let's do this. Let's go to a different color. Let's put a point right here. And let's find the coordinate. We've already done this once with the 5, 4, but let's do it again because we're in a different quadrant. Leon. So let's find the coordinate of this point. So where do we start? At the origin. This time, instead of going right, we go what? Left. So let's count. 1, 2, 3, 4, 5 to the left and 1 up. So the coordinate of this point would be, yeah, but it's not 5 because we went to the left. Right, it's -5, and we went up, so it's +1. So I should have done this. If you go to the right, it's positive. If you go to the left, it's negative. If you go up on the y-axis, it's positive. If you go down on the y-axis, it's negative. Everybody, yes? I'm going to. I'm getting there. Thanks. I'm good. So you know this stuff. That's great. But I'm doing the points first, and I'm going to look at the signs, okay? Let's do another point. Let's go right here. All right, see that point right there? Let's find the coordinates of that point. Start at the origin. We go 1, 2 to the left, so that's -2. And then we go 1, 2, 3 down. So that would be what? -2, -3. See that? All right, let's do one more. Let's do one way out here like this. All right, if I could count over that far, let's see. 1, 2, 3, 4, 5, 6, 7 to the right, and 1, 2, 3, 4, 5, 6. Yep, 7 down. So I went 7 to the right and 7 down. So what's my coordinate? 7, -7. Okay, and that's the coordinate. All right, and let's just put 5, 4 right here. All right, this is what Trent was talking about. In the first quadrant, every single point in the first quadrant is going to have the signs positive, positive. You see that? Because to get the first quadrant, you have to go to the right, which is positive, and you have to go up, which is positive. So it's positive, positive. What are my signs going to be in the second quadrant? Negative, positive. Okay, the third quadrant? Negative, negative. And then in the fourth quadrant, positive, negative. All right, because we go to the right and we go down. All right, let's do this. Try a different color. What if I put a point right there on the y-axis? So this is a little different. It's not in a quadrant. Okay, if the point's right on the axis, it's not in the quadrant. So what if I put a point right there? I start at the origin. Now, how far do I go left and right? I don't go anywhere. Okay, so I go 0, correct? And then I go what? Up. 1, 2, 3, 4, 5. So this is, let's listen now. So this point right here would be 0, 5, right? I didn't go anywhere on the x-axis, so I put a 0 for the x. But then I went up 5, so it's a positive 5, 0, 5. What if, let's put a point right there. What's the coordinate of that point right there, that pink one? That's right. So I do go left and right. So I go left, 1, 2, 3. But then I don't go anywhere, right? I'm already there. So this would be negative 3, 0. So that's the coordinate of that point right there on the x-axis. I don't know, this just popped in my head, but I got one axis, I got two axes. Do I call them like axes? That sounds kind of weird, doesn't it? What's the plural of axis? Anybody know? It's axes. Okay, this is the plural. I'll put PL for plural. So the plural for, if I have two axes, okay, I don't usually pronounce the E that big, but axes, okay? So I say I have two axes, the X and Y axis. You got quadrants. You got all this good stuff. Let's see, is there anything else? Nope, that's pretty much it, okay? So that's just, it's not the whole lesson by any stretch. There's a lot to lesson 3-4. We'll probably, listen please, let's not talk. I'm still talking. Shh. So this section 3-4 is pretty long. So it's going to take us probably 3 different class periods even after today. So counting this, probably 4 different class periods to get through all of section 3-4. In between each of these sections, because what we're doing first is we're doing distance first. Okay, then after distance, we're going to do midpoint. Yeah. And then we're going to do a thing called slope. Okay. All right, so we're going to do, so this section is called, I believe, it's called, yep, distances, slope, or midpoints and slopes. So this is just the first part of it, okay? So we're going to do distance. We haven't even talked about the distance between 2 points. So here's just a sneak preview. So if I had a point right, I don't know, let's use this yellow one. Now it's pink. Okay, this point right here and this point right here, if I connected this point to this point, I'm going to figure out how long that line is right there. Okay? That's what we're going to do on this section 3-4. Okay?